Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at kinematics. So we're going to look at using calculus to solve problems involving displacement, velocity, and acceleration. So it's really important firstly that we understand the difference between displacement and velocity. Now we're about to look at an example about a rocket being fired straight up in the air. So this might be, say, ground level or from where it started. So above that, the displacement is positive, and below that, the displacement is negative. So displacement, as well as velocity, it is a vector quantity. It has size or magnitude as well as direction. So unlike distance, displacement can be negative. Similarly, velocity, unlike speed, can be negative. So if the velocity is negative, it would mean the rocket is going down, and if velocity is positive, it means it's traveling up. Whereas the speed that that you've learned since year 7 or whatever, speed can only be positive. It's a scalar quantity. It only has magnitude. Distance and velocity are vector quantities. Acceleration is also a vector quantity. Has both size and direction. So if the acceleration's positive, it means that the velocity is increasing, and if the acceleration's negative, it means that the velocity is decreasing. So the link between the three can be shown here. So if you differentiate displacement, you get velocity. That's because velocity is the rate of change of displacement with respect to time. Similarly, the derivative of velocity is acceleration, because acceleration is the rate of change of velocity with respect to time. If you want to go the other way, you integrate. So go from acceleration to velocity, you integrate. To go from velocity to displacement, you integrate again. All right, let's look at putting this together in this question. A rocket is fired straight up in the air, initial velocity 39.2 meters per second squared. So we're going to do all this, calculate average speed, average velocity, and the velocity when it hits the ground. So we aren't actually told here, but we know what the acceleration is. The acceleration due to gravity on Earth is negative 9.8 meters per second squared. That means if something's traveling up, it loses 9.8 meters per second of speed every second. It's negative because acceleration reduces the velocity. It stops things from going too quickly upwards and brings them towards the Earth. So that's the acceleration of pretty much all objects on Earth. So if you fire a rocket straight up in the air, this is what will happen to its acceleration. So here we're not considering any sort of air resistant, we're just looking at acceleration due to gravity. So I can find a function for velocity, because velocity is just the integral of acceleration. So it's going to be negative 9.8, but it's with respect to t, which is time. So the integral of negative 9.8 with respect to t is 9.8t plus c. So what would be c here? Well, the initial velocity was 39.2 meters per second squared. So we replace c with 39.2. That is the value of v when t equals 0. So what about the displacement equation? Well, to find that, I'm going to integrate velocity. So if I integrate this, I increase the power by 1 and divide by the new power, I get negative 4.9 t squared plus 39.2 t. Now, I don't need a constant here for displacement, because the displacement at time 0 was 0. The rocket hadn't actually traveled at all. So here the displacement can be seen as the height in meters, because everything was in meters, the height in meters above ground level. So let's calculate first the average speed. So we need to know how far the rocket went up or down. So how far did the rocket go up? Well, the maximum distance it attained is when its derivative is equal to 0. But hang on, the derivative of displacement is just velocity. So it's when 9.8t plus 39.2 equals 0. So you can easily solve this equation and get t equals 4. So what that means is the maximum displacement was reached after 4 seconds. In other words, the rocket went up for 4 seconds and then it stopped and turned around and started falling back down towards the Earth. So the distance after 4 seconds, all I do is substitute that here. So I get 78.4. That means the rocket reached a maximum height of 78.4 meters. So that means the rocket traveled a total of 156.8 meters. It traveled 78.4 up, 78.4 down. So the distance traveled is 156.8, and it would have taken a total of 8 seconds. 4 seconds up and 4 seconds down. And so we get 19.6 meters per squared. That was the average speed of the rocket. Notice, it's no coincidence, this is exactly half of the velocity. Okay, so that's the average speed. What would be the average velocity? So call this average S for average speed. So the average velocity, it turns out, is 0. Why is that? Well, velocity is displacement time. If the rocket started on ground and finished at the ground, then it has a 0 displacement over the whole 8 seconds. So that's why the average velocity is 0. Now, what is the velocity when it hits the ground? Okay, so when does it hit the ground? Well, we know it's 8 seconds, but if you didn't know that, you could actually just solve this equation here. You'd find displacement is 0, and solving that equation here, you get t equals 0 or t equals 8. So what that means is it hits the ground again after 8 seconds. Starts at ground level, goes up for 4 seconds in a straight line, and then it hits the ground again after 8 seconds. So let's find the velocity after 8 seconds. All I need to do is substitute 8 into this expression here. And it turns out I get v is equal to 39.2, but negative. Now it's negative because it's traveling towards the ground. Now velocity is always in like meters per second, kilometers per hour, or whatever. So this was the instantaneous velocity, the velocity of the rocket when it hit the ground, even though the average velocity there was 0. So the point I want to make here is a lot of people don't quite understand. Let's say we have this displacement function. Now you know that that's a parabola. It's a parabola that's going to look something like this with a maximum at 4. Now this isn't the trajectory of the rocket. The rocket is not going up and horizontal. This is just a function that represents its height above ground level after a certain time. The rocket is actually traveling straight up and straight down. So we're only looking in kinematics at straight line motion, objects traveling in a straight line, not objects traveling like up and horizontally. Again, this is not the trajectory of the rocket, it's just a function that tells us the height of the rocket after a certain time. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.